Now let's start chapter number 7, in which we will talk about data location, storage versus memory. Inside there are two locations you can store variables in: storage and memory. Storage refers to a variable stored permanently to blockchain. Memory variables are temporary and are erased between the external function calls to your contract. Think of it like your computer's hard disk versus RAM. Most of the time, you don't need to use this keyword because Solidity handles them by default. State variables, state variables declared outside the function are default storage and written permanently in the blockchain, while variables declared inside the function are memory and will disappear when the function call ends. However, there are times when you need to use these keywords, namely when dealing with structs and array within functions. So here it is, we are creating an struct and we are creating a struct array. Then there's a function where we can just put it my sandwich is equal to sandwich index. We can put it like that, but it will give a warning in your sorry compiler. So we should use the keyword storage, in which my sandwich is a pointer to a sandwich index in storage. This will permanently, if we just put the value inside the status, there it is. It will permanently change sandwich index on the blockchain. If you just want a copy, you can use the memory, in which case another sandwich will be simply be a copy of the data in memory. Another sandwich dot then will just modify the temporary variable and have no effect. So, but the difference between the memory and storage is storage right permanently on blockchain, whereas memory is just at the scope of the function. Once the function executed, then the value will be just removed from here, from it. So if you want to store something on blockchain, so you should use a storage keyword. So now let's move on to the syntax. There could be, but you can do it. We will just modify temporary variable and have no effect on sandwich index 1, but you can do this if you want to copy the changes back into the blockchain storage. Okay, so here it is. If you just want to copy it to the blockchain, then we can use this syntax. So don't worry if you don't fully understand when to use which one yet. Throughout this tutorial will tell you when to use storage and when to use memory. And the Solidity compiler will give you warning to let you know when you should use one of these keywords. For now, it's enough to understand that these are there are cases where you need to explicitly declare storage or memory. Put it to test. It's time to give our zombie the ability to feed and multiply. When a zombie feeds on some other life form, its DNA will combine with the other life form's DNA to create a new zombie. Create a function called feed and it multiply. It will take two parameters underscore zombie unit and underscore target array. The function should be public. Okay. Now let's create a function here in the new smart contract. Function name is uh, function feed and multiply. Okay, so there are two parameters: zombie id int underscore target DNA. Okay, that is feed and multiply in zombie id and you int target DNA. Okay. We don't want to let someone also feed our zombies, so first we need to make sure that we own this zombie, and I require this statement to verify message or sender is equal to the zombie owner. That's similar to how we did in the create zombie function. Okay, so what we need to do is we need to check that this particular zombie should be uh, this function should be called by the owner of the zombie. So here we can just check it by underscore zombie id. Here it is, because we have inherited it from zombie factory, so we can have all public variable access inside it. So here it is, zombie to owner, and here we have a zombie id and should equal to message dot sender, the one who is calling this function, similar to how okay. Note again, because our answer checker is familiarity is explicitly accepting it to come first. Okay, so we need to make set it first. So it required for it to check. Uh, Now let's see. Now third task is we are going to need to get the zombie DNA. The next thing our function should do is declare a zombie named myZombie, which will be storage pointer. Set this variable to be equal to underscore zombie id in our zombie array. Okay, so here it is. We are going to get a zombie DNA. So function should be declare a zombie named by zombie id by my zombie. Here it is storage my zombie. Set the variable to be equal to zombie underscore id in our zombie array. I think we have to define it something like this. Set this variable. Okay. So basically, none of us one including the line zombie ID. Okay, sorry. So we need to just define it like that. Okay, let's test it. Yes, great. So here we have covered storage versus memory, and we have done the exercise as defined here. So we have completed chapter number 7 also. Now let's move on to chapter number 8.